Hello students, now today we are going to start the topic that is CRO. CRO. This CRO is nothing but it is a cathode ray oscilloscope. Okay students, this cathode ray oscilloscope is an analogous measuring instrument which displays rapidly the changing or a high frequency voltage against the time in a form of a graph seen as a bright trace on a screen. Okay, as you know, this CRO it is used for an engineer. CRO it use engineers for measurement purpose. As the physician uses the stethoscope for the measurement of the heartbeat, we are using this CRO as a testing. Okay, in a most widely the used instrument for investigation also. Okay, so there are the various different blocks which represents the CRO. Now we will see the different blocks. This CRO it is a cathode ray oscilloscope. Cathode ray oscilloscope. Okay friends, it is the cathode ray oscilloscope. Now we will see the different blocks of the cathode ray oscilloscope. So very first you have the vertical attenuator. Here vertical attenuator. Second block it is vertical amplifier. Second block it is vertical amplifier. Third block it is a delay. Okay students, so these are the three blocks. Apart from these three blocks, this CRO, as earlier topic I told you, the CRO is nothing but it consisting of a CRT tube also. So here we are going to draw the CRT tube. It will look like this. It is a CRT. Okay, the simple way we are going to draw this one, CRT. The vertical and the horizontal, it is the vertical part, it is the horizontal part. Vertical deflection plate and the horizontal deflection plate. This vertical deflection plate is being get connected with a delay line like this. Okay, in this CRT there are the different pins. The pins have been shown like this. Inside this CRT there is a control grid. Okay, the filament is also present. So this filament and the control grid is been indicated like this. And here are the different types of the pre-accelerating, accelerating, focusing, pre-accelerating anode, focusing anode, and the accelerating anode. Pre-accelerating anode, focusing anode, and the accelerating anode is indicated here in this CRT. Okay, now this horizontal has to be get connected with this horizontal amplifier. Horizontal amplifier. One part and the second part like this. Okay friends, this diagram is very much important. Okay. Now this horizontal is again get connected with it is nothing but it is a time based generator. Time based generator. It is get connected with a circuit. It is called as a blanking circuit. Blanking circuit. Okay, this blanking circuit is being get connected with a control grid of a CRT. It is a control grid. Just I will give you the name. control grid of a CRT. It connects with the blanking circuit. Okay, this horizontal amplifier is been get connected with this, gives you the internal and the external part, which is connected with a time based generator, and this time based generator is been get again connected with a triggering circuit. Trigger circuit, or just you may say that it is a trigger. This trigger circuit is been get connected with a vertical alternator like this. Okay, and here the external trigger or external synchronization signals are to be get applied. In this, the time per base or a time division we are going to measure. Here the different types of the voltages, that is, we are giving the high voltage and the low voltage for high voltage and the low voltage power supply. Okay, power supply, high voltage power supply and the low voltage power supply. Vertical alternator, here we have to give the input value. Okay, whatever the cable has to be get connected, it is inputted with that particular channel number 1 or a channel number 2. So inputted value with a Y signal, here it will produce the volt per division. Okay, and here the internal and the external, it produces the X axis, means in an X axis we are going to measure the time per division. Here the X axis means time per division is going to be measured. So this is the complete diagram. It is a complete diagram for a cathode ray oscilloscope. Okay students, now we will see the how the vertical alternator and the vertical amplifier is going to be work. This vertical alternator or the vertical amplifier, the signal, the waveform to be observed on the screen is applied to the vertical amplifier, this vertical amplifier, and from this particular vertical amplifier, from where the signal is going to become, it is come from the vertical attenuator. This vertical attenuator, through it gives the gain of the amplifier is set by calibrating the vertical input amplifier attenuator by using the volt per division. We are just adjusting the voltage per division control button, and the push and pull output of the amplifier is fed to the vertical deflection plate of the CRT through the delay line. Through this particular delay line, the vertical deflection plate assembly has been get inserted. The use for this particular delay line, the delay line is used to delay the arrival of the input waveform in a vertical deflection plate. Okay, whatever the vertical alternator or the vertical amplifier, whatever the signal is to be get applied, it gets delayed, and due to that particular delay, it has a chance to start the sweeping value. This sweeping value is nothing but, you may say that this is the sweeping value. Okay, so here this signal is going to be get occurred, and due to that particular signal, it gives approximately a 0.25 microsecond. Okay, whatever the length has been get occupied by that particular delay line, it is 0.25 microsecond in a vertical deflection channel. Okay, then comes the triggering circuit. This triggering circuit, or you may say that it is a synchronization circuit. The stable CRT displays can be maintained in the starting for the horizontal sweep at that particular time on a signal waveform. The time base has to be get again occurred. It is related with the time base, and in this time base we are going to measure the time per division value, and due to that particular time per division, it is been get adjusted by some particular keys, and due to that we will be able to measure the x-axis, the time per division. Means we are going to measure the horizontal value, means this horizontal amplifier come into the existence. This horizontal amplifier is being get attached with the horizontal deflection plate, and due to that we are able to measure the x-axis, and that x-axis is nothing but it is a time per division value. Okay students, this horizontal amplifier is very much important. This horizontal amplifier amplifies the phase inverted value. Okay students, then the high voltage and the high voltage power supply and the low voltage power supply has to be get occurred for making this to be in a on condition. Okay, so this is all about the cathode ray oscilloscope. Okay, thank you. Then necessity of time base in the CRO, we will see. For what the necessity of a time base? The CRO, it usually displays the vertical input waveform. Okay students, what it displays? It displays the vertical input waveform as a function of a time. Then how that particular wave, the necessity of time base, necessity of time base. Here you are going to observe the wave. That wave gives you the retrace time and you are getting the sweep time. How that retrace time and the sweep time is going to be get occurred? It is shown with a diagram. This diagram with a waveform, it is being get indicated. This is the value which you are getting, and suppose if we raise the value, you are getting the V minimum voltage, and here we are obtaining the V maximum voltage. Okay students, in between particular V minimum and the V maximum, we are spotting the value. As we have seen earlier the block diagram, in that block diagram the horizontal deflection voltage is very much necessary for the x-axis for measuring the time per division. Okay, that particular sweep value in the CRT, it spots across the screen that whatever the electron generated, and it has to be get passed from the anode cathode. Okay, it has to be get passed from the different acceleration. Okay, the accelerating anode, the focusing anode. Okay, and previously it is a pre-accelerating anode. First pre-accelerating anode, then second it is a focusing anode, and third it is the accelerating anode. When the electron passes from this particular anode, it goes to the vertical and goes to the horizontal deflection plate. Okay, vertical deflection plate, when it goes, it maintains the horizontal direction, and as soon as the electrons pass from the horizontal, it tries to maintain the vertical direction. Okay, when that electron spots on the screen, okay, when the electron spots across the screen from left to right with a constant velocity, the spot then suddenly returns to the starting position of the left hand side of the screen, and that sweep voltage is called as a time base. Okay students, here we will be marking the minimum and the maximum. Like this we are marking the minimum and the maximum value of that particular voltage. Here this gives you the value like this. Okay, so this part and this part, this is the part which has been used by us, and it is nothing but it is a TR, and from here to here the sweep value, the sweeping start, it is nothing but it is indicated with the TS. So from this here it is very much clear to you that the TS value means a sweep time. TS, it is a sweep time, and TR, it is a retrace time. This retrace time is also called as a flyback time. In that particular time based signal, it rises at a linear rate for some minimum value to the maximum value, and then returns suddenly to the original level. It rises from this particular minimum value to the maximum value, and then again it returns to this original value, and then again it tries to rise from the minimum to maximum. Then again the sweeping time, this sweeping time and the retrace time you are getting in that particular CR. Okay, apart from that particular this one, you have the time based generator, and that time based generator is nothing but it is also called as a relaxation oscillator. We will see that particular relaxation oscillator. It is a time base generator. This time based generator is nothing but it is a relaxation oscillator. Relaxation is nothing but for some while, relax oscillator, for some while the waves is being get relaxed, and for you obtaining this particular we are using the UJT. The UJT is nothing but it is a uni-junction transistor. In that uni-junction transistor, the two types of the bases has been given to and one emitter has been assigned to you. In that particular basis, we are going to connect the resistance. That resistance will give you the value. That value is nothing but it is a B1 value, R1 value and the R2 value. Or you may say that the two bases have been assigned, that is RB1 and the RB2. So here it gives the symbol for the UJT like this. Either it is NPN or either it is a PNP, we are going to indicate with the arrow. Okay, the simple UJT we have drawn. In a base 1 and in the base 2 we are going to connect the resistance. So here we have resistance like this connected. We are going to connect the resistance like this, and whole it is been get connected with the RC network. The emitter, okay, the resistance value and the capacitance is get connected with this resistance. It is RB1, it is RB2, it is a variable resistance, and here we are going to connect this value. But as it will work, no, when we will give the voltage, okay, that voltage is nothing but it is a maximum voltage. Okay, that maximum voltage for the relaxation oscillator, it is very much important, and that voltage has to be get obtained by this. Here you may say that V max. If it is positive, then here it is grounded. Okay students, so this diagram is very much important for you. When we obtain the output, from where the we are getting the output, from here we will get the output. In the same way, the input is going to be get applied by this particular formation, and the output will be get occurred. This output will be get measured like this. Okay, there are the waves, how the redress and how the sweep is going to be get occurred. We have seen like this. If the relaxation oscillator comes, we are getting that particular sweeping value and the redress value like this. Again the same thing, but here the sweeping and the redress will be indicated with the one particular relaxation value. Again the same, you are obtaining the minimum and the maximum voltage and the maximum VM voltage you are going to obtain. Here if we indicate this one like this, then you may say that it is a Vmax, it is the voltage, and here it is a Vmin. Again the what value you are getting? You are getting the sweep time and you are getting the redress time. The sweep time and the redress time will be indicated with this particular block, and since you may say that the time based generator is called as a relaxation oscillator. As soon as you are getting that particular relaxation or oscillator, the eta value is going to be occurred, and that eta value is nothing but it is an intrinsic standoff ratio. This intrinsic standoff ratio will give you how the redress time and the redress time and the sweep time is going to be occurred. Okay, in that particular UJT, in that the time base or a sweep generator, it acts as a switch. When the power is applied, okay, when the power is applied to this particular capacitor, it charges exponentially through the resistor. When the capacitor, we are applying the charges, it charges through this particular resistor, and the emitter voltage and the emitter voltage, this emitter voltage, it is indicated with the E. It is indicated with the E, and when this emitter voltage increases the supply voltage, that is a V set, or you may say that the base to base voltage, you are getting the value equal to that particular peak value. Okay, in that particular peak value, the junction is in a forward bias, and since UJT will be get turned on, and due to that particular turn on, we will get the Vp value. Here the Vp value, we will get Vp is equal to, when the intrinsic standoff ratio for that particular it is been get occurred, you are getting the neta into VBP plus 0.6. This 0.6 is nothing but it is the forward value. Okay, now the neta which is going to be indicated, that neta I told you it is a intrinsic standoff ratio. In that intrinsic standoff ratio, whatever the resistance value, this RB1, RB2, you are going to be occurred, that RB1 and RB2, the neta is equal to RB1 divided by RB1 plus RB2. You are going to be get occurred. Okay, since when you put this particular thing in this part, means the UJT is turned on due to this one, and the capacitor discharges. As soon as it discharges, the UJT provides the low resistance path for the emitter and the base. Through this particular emitter and through this particular bases, it provides a low resistance path. The value for the VE will get decreased to the value for this particular V will get decreases to that particular V minimum value. This V minimum value will be get occurred. Okay, and at that particular the UJT will be get turned off, means it will not in a working condition. Since the capacitor charges, but the capacitor is charging, this cycle of charging and discharging provides a saturated waveform, and that waveform is nothing but this is the waveform which is drawn by me. Okay, there are the variable controls also. In that particular CRO, there is a variable control. It is used for controlling the frequency which varies with the R, means this R, and the time per division controls the charging of the capacitor C. Because when we are using the time per control, means we are adjusting the value for the x-axis, means the time is going to be get controlled, and due to that the number of the frequency is going to be ranges, which will be get occurred, and due to that occur of the frequency, we may say that this is used as a relaxation oscillator. Okay students, now we will see how the CRO displays the waveform. The DC voltage we are going to apply with the horizontal deflection plate. Okay, means in the horizontal we are going to measure the time, and in the vertical we are going to measure the voltage. These two things you have to keep in your mind. The CIT spots moves from the plate where it is a positive potential. Okay, so you have this wave. How the wave is going to be get moved? Like this, the wave is moving. Okay, we will mark here as a ABCD. Here A, B, C, D, E, F, G, I, J and K and so on. Okay, as soon as the wave is going to be get occurred like this, the A, B, C, D we are marking the position, and the AC voltage we have get obtained. In that particular AC voltage to the horizontal deflection plate, the spots moves from one left side to the right side at a one particular rate of the frequency. This spot moves from this particular left side to the right side at a one particular frequency. It is equal. The frequency is equal to each and every cycle. This frequency is equal to each and every cycle. Okay, the sinusoidal or that particular signal is a line which is being get produced. Now in this particular line, what we are going to indicate? We are going to indicate this value. Okay, here only we will draw this one up to this I. When you are obtaining that particular value, some value is being get occurred, and that value occurred we are going to observe in the CRO screen. How that? We want to observe the waveform on the screen. To get observed should be applied to the vertical plate. Whatever the value is going to be get observed, we have to apply that value with the vertical plate, then only it is possible to see the waveform in the CRT screen. Now in this CRT screen, here from A to B, B to C, C to D, D to E, then F, E, G, H, I. The same thing will be get displayed, but in a particular image form. That image form will be indicated with a same value like this. Okay, so this is the value which will be get occurred, and that value will be again get marking, and you are getting the image. This is the image of that this wave. What we are marking? We have marked the value, that is A, B, C, D, E, F, G, H and I. The same value we are getting in that particular wave. As the sawtooth wave edges form increasing linearly with the time, the CRT spot moves across the each and every value with a constant velocity from left to right. From this particular constant velocity, this value will be get moved in a constant speed. Okay, at the end of that particular sweep time, at the end of this particular sweep time, at the end of this particular sweep time, you are obtaining the voltage suddenly drops from maximum value to the zero value. Here the maximum value for the positive and the maximum value for the negative. As soon as it gets dropped, it comes below. Okay, due to that, the influence of the second force, the electrons beam moves vertically according to the magnitude and the polarity of the input signal. Okay, whatever the polarity is going to be get occurred with the input signal, it get moves, and due to that the resultant motion, whatever the resultant motion is going to be occurred in the electron beam, it produces on the CRT, it displays on the vertical input signal as a fraction of a time. Okay, the simultaneously application for that particular deflection voltage to both the sets of the plate that causes the CRT spots to trace on the image of a screen. Means in that particular if you observe that particular screen in a box, you are getting the image, and that image is been indicated like this. And at a one particular instant, if that image we are going to mark, we will get the time base in the x-axis, and in the voltage we are getting the value for the y-axis, which is a voltage maximum. Okay, so here we will see, suppose this is the part which we are going to be get observed. So just mark this value, this value, this value, and this means a quarter value we are going to mark. We will mark this quarter value in this particular inclined line. It is a line which has been get marked by us, and that line we will just see okay. Now the one horizontal line, one vertical line will be get occurred. Horizontal and the vertical line will be get occurred. That horizontal and the vertical we have to mark, and that marking will give you the A, B, C and D value. Here like this, and at the end this zero value. What is the value for this one? It is B. It is C, D, E, F, G, H and I. Okay students, the A value, it is the A value having that position particular starting from the 0, and you are getting that particular 0, it is nothing but it is a time base. That time base signal is recorded as a X input. Okay, it is a time base, means a X input. Then we have the value with the voltage. That voltage is nothing but this one, or you may write down this one as a voltage. Okay friends, in this way the CRO displays a waveform. The next is the front panel for the CRO. The front panel for the CRO, it indicates front panel of a CRO. In this front panel of the CRO, one block has been drawn by us. Okay, here you will be observing the block, means a front panel like this. Okay, this is the front panel, whatever the portion you are viewing by your eyes frontly. Here the same portion. In one corner there is a CRT screen with a number of lines present like this. They are the small line with the equal distance. It is a 1 centimeter, 1 centimeter block has been assigned. Okay, there are the 10 lines horizontal and the 10 line vertical, means a 10 by 10 screen is being present there. If that screen is a dual, means you may say that it is a dual trace CRO. Either you are getting that CRO with a single value or a double value. But some CRO is of 20 megahertz. 20 megahertz wave is going to be calculated, or you may say that it is of 25 megahertz. Up to this we have seen. Okay, generally up till our study also we have seen these two CRO, and one CRO we have observed, that is a single trace CRO which is vertically placed. But this CRO, it is a dual trace CRO. Why it is called as a dual trace CRO? Because in that CRO the two vertical per division buttons are present and the two channels are present, and that's why you may say that it is a dual CRO. Due to that one, at a time you are able to view the two waveform in this screen. Okay, this screen contains a two waveform, and that's why you may say that it is a dual trace CRO. Okay, it is a dual trace CRO. Here you have one block, here you have one block like this. Okay, it indicates the channel number 1 and channel number 2. It indicates channel number 1 and it indicates channel number 2. Just beside this channel number 1 and channel number 2, you have a button. That button is nothing but it is indicated with a voltage per division button. Voltage per division button. Okay, apart from this button, the CRO has to be make on and the off. So here it is a on button and off button. On and off button. Then if you want to adjust the intensity, then the intensity button is being provided. If you want to adjust the trace, there is a one small clip. Due to that particular clip, we have to make adjustment of this line, either it is tilted or something. So here one trace button is present with a screw, adjustable screw. Then the focus, if you want to make sharper the image, then the focus has been assigned. It is a trace button, it is a focus button. And apart from that trace, if you want the wave to be displayed in a square or rectangular, then here there is a square or the rectangular facility has been given to you. Okay, after this one, here there is a one block. If you want to measure the wave, either the AC wave, either the DC wave, or you have to make that particular wave as a ground, here the three blocks have been assigned to you, means a 12 button is present. Due to that one, you may adjust to the particular ground terminal, or you want to measure the positive value or you have to measure the earthing value. It is present for the both channel. Then there is a different, it is all about the measurement of the voltage. Okay, in the which axis? In the y-axis. Now if you want to measure, you have to take the frequency also. So that frequency has to be get observed by using the time per division. Without the time per division, the CRO is not possible. Okay, so here there is a separate block that gives you the time per division knob. Will not say the button, you may say the knob. Time per division knob, volt per division knob, and these are all the different knobs which is present. Okay, so the time per division, it is used for measuring the x-axis. Means generally the frequency we are going to measure. By using this, we are going to adjust that particular button, and after adjusting we will say that this is the time or this is the frequency which is related to that particular waves. Okay, here there is a one level button has been given to you. If you want to adjust the x-axis and the y-axis, the again one small button has been assigned to you. This all we will see in original CRO. Okay students, so let's go and see, observe that particular CRO. Hello, थोड़ा समोर घे, समोर घे थोडंसं. दिसू दे झालं, पुन्हा ये जवळ, दिसू दे, पुन्हा ये जवळ. Hello student, now this is the CRO. This CRO is of a 20 megahertz dual trace CRO. Okay, you are observing this instrument. This instrument is the signal generator. This signal generator, it generates the waves, and this wave from this particular cable we are going to view this wave in the CRO. The full form for that CRO, it is a cathode ray oscilloscope. In this cathode ray oscilloscope, here you are observing this one particular part. It is the CRT. This CRT, the full form for the CRT, it is a cathode ray tube. In this cathode ray tube, there are the number of the vertical lines and the horizontal line. In this vertical line and the horizontal line, there are a small one lines are present. If you are able to view this one line, small lines, means one box, it consists of a 1 centimeter. As per the scale, 1 centimeter, 2 centimeter, 3 centimeter, here the number of boxes has been assigned to you, which consisting of a 1 centimeter box. So when you observe 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, the 10 centimeter, 10 by 10, the screen has been assigned in this CRO. Now we have to study the detail part. This wire is nothing but it is the CRO probe. This CRO probe, this is the special type of the connector which is called as a BNC cable. It is called as a BNC cable. The full form for the BNC is nothing but it is a British naval connector. Okay, British naval connector. This connector is attached in such a way that it is get connected like this. Okay, so that what if anyone pulls, it does not strike out. This is the channel number 1. And this is the channel number 2. As the name indicate, the dual trace, the channel number 1 and channel number 2 has been assigned in this CRO. Okay. Apart from that, here this is the power button. This is the power button. This is the intensity button. This is the focus button. By using this power, we can make the CRO on and the off. Okay. By using this focus button, if you want to make a brightness, then this focus has been used for controlling the brightness, this focus, and for the intensity, the brightness, the focus. If you want to make the wave very sharper, this focus has been used. Then the X1, if you want only measure the y-axis, then if you are able to trace this X and Y, ultimately one line has been shown in the screen. You will be able to measure the cut-to-cut value, that is a BPP value for the Y in a sine wave. Okay, then come to back to this one. This is the vertical on and vertical off for the TV. That is a horizontal and the vertical value for the TV measurement. This is the frequency filter. Here you have seen the AC, DC, HF, VHF, LF and the sine. It is nothing but it is a frequency filter. And apart from these two, voltage per division for the channel number 1, voltage per division for the channel number 2 has been assigned to you. Apart from these two channels, you have the time per division button. This time per division button has been divided into the 1, 2 and the 3 part, that is the second, millisecond and the microsecond. The second part, it starts from 1 to 2. Then microsecond, it is having the value 50, 20, 10, 5 to 1, 0.5, 0.2 and 0.1. These are all the millisecond button assigned for the time per division, and this time per division in the CRO we are going to measure with the x-axis. Okay. When this knob has been assigned to this particular value, this value has to be get multiplied how much number of a division assigned for a one complete cycle. That one complete cycle is nothing but if you are able to measure this wave to the 360-degree value, how much boxes, how much numbers has been get cut, and that value has to be get multiplied with a time per division, so that you are getting the time, how much time the one wave has been assigned in this CRO. Then comes this x position. If you want to move the wave to the x to the left side and the right side, then this x position has been assigned. Means the horizontal line has been has been used for moving the x and y x position. Okay. If you want to move that particular waves to the upside and the downside, okay, means vertically you want to move, then this is the position, the y position you want to control. By using this particular knob, you are able to move the waves up and the down. Okay. Then comes magnitude. This magnitude, it gives you the maximum length of the waves. Here it is the invert. This is the positive and this is the negative. If you want to invert the waves, then this button here, the invert has been written. If you press this invert button, the positive will get changed to the negative and negative will get changed to the positive. In this way, the invert is going to be work. Then it is a component tester. If you want to test any component by using this CRO, this component tester has been used. The small knob has been given to you, and this one, if you press here, it will display the different values. Okay. Then here it is of a AC, DC and the ground. If you want to measure the AC wave, you have to keep this probe, this pointer to the AC. If you want to measure the DC, then it has to move to the DC. Then if it is grounded, then this grounded portion has been assigned. Okay. Then this one is the position for the channel number 2. This one is the AC and the DC value assigned for the channel number 2. Okay. Here is the inverted for the channel number 2. As per wherever you are going to connect this probe, if it is connected to this one, then it is the channel number 1. If this probe is connected to this one part, then it is the channel number 2. If the wave doesn't come, we have to adjust in such a way that we should be displaying the wave to the sine or. And one thing, in this CRO, it is not compulsory that only the sine wave is being get generated. It generates the square wave also, it generates a ramp wave also, and also it is used for measuring the Lissajous method. Okay, in a CRO, there is a frequency. The two types of the frequency has been assigned to you. The Lissajous method has been assigned. That Lissajous method in the CRO, it is being used. Okay, in a practical, when we observe the Lissajous, the different x value and the y value, the x-axis and the y-axis value has been assigned. How much waves has been given to you? It has been shown in this particular screen, and according to that, the magnitude has been assigned, and due to that particular magnitude, we are able to measure the waves. In this particular signal generator, it is having a frequency which is starting from the hertz, that is 1 to 10 hertz. It is the frequency multiplier starting from 1 to 100k, and the waves with the amplitude 0.3, 3 and the 30 volt. Wherever, if you just change the value, change this particular knob, you are going to observe the wave like this. Okay, the waves will be get changed, or it will be get disturbed, or you will be getting the measuring that particular value by only constant wave. By only the constant wave, you are able to measure the constant value for the x and the y, and since the voltage and the time is going to be calculated. Okay, this much is all about the CRO, the study for the CRO. In your examination, the 4 mark question is going to be asked in CRO. So this much you have to write down. Okay.